What is the Bloch sphere in quantum computing fundamentals? Have you ever wondered how we visualize the complex world of quantum computing? One fascinating tool that helps us do just that is the Bloch sphere. So, what exactly is the Bloch sphere, and why is it important in quantum computing? The Bloch sphere is a geometric representation that allows us to see the state of a single qubit. A qubit is the basic unit of quantum information, and it behaves quite differently from a classical bit. While a classical bit can only be in one of two states, either 0 or 1, a qubit can exist in a superposition. This means it can be in a combination of both states at the same time. The Bloch sphere captures this unique behavior by representing every possible pure state of a qubit as a point on the surface of a sphere. On the Bloch sphere, the vertical axis represents the classical states. The north pole corresponds to the state labeled 0, while the south pole represents 1. Any point on the surface of the sphere shows a superposition of these states. This is defined by two angles, theta and phi. Theta is the angle from the positive z-axis, and phi is the angle around the z-axis. The state of the qubit can be described by a vector, known as the Bloch vector, which originates from the center of the sphere and points to a specific location on the surface. This visualization is essential for understanding several key concepts in quantum computing. For instance, the Bloch sphere illustrates superposition clearly. It shows how a qubit can be in a continuous range of states between 0 and 1, unlike classical bits that are limited to discrete values. When it comes to quantum gates, these operations correspond to rotations of the Bloch vector around the sphere's axes. For example, the x, y, and z gates rotate the state vector around the x, y, and z axes respectively. This makes the Bloch sphere an intuitive tool for understanding how quantum gates manipulate qubit states. Another interesting aspect is the angle phi, which represents the relative phase of the qubit state. This property does not have a classical equivalent but is vital for quantum interference effects. While the surface of the Bloch sphere represents pure states, points inside the sphere representing mixed states. These mixed states are statistical mixtures of pure states and often occur in practical quantum systems due to noise or decoherence. In the realm of quantum computing, the Bloch sphere is widely used for teaching, debugging, and designing quantum algorithms. It provides a clear visual way to grasp how qubits behave and evolve under quantum operations. However, it is important to note that the Bloch sphere only represents single qubit states and does not account for entanglement, which involves correlations between multiple qubits. Overall, the Bloch sphere serves as a foundational concept in quantum information theory. It offers a straightforward yet precise way to understand the nature of qubits and their manipulation in quantum computing.